a little bit about how to prepare a project for reservoir simulation, so which is called defined simulation model. And so let me show you something. So okay. So in order to make defined simulation model, we have to prepare 3 steps. So first is to prepare fluid model, fluid properties. Then it is preparing rock properties. And finally, it is preparing development strategies. After we would finish all those steps, we would be able to define simulation model, which is actually, let me show you. So as the result of defined simulation model process would be creating this folder. You see, so you see, I have a model which is called Nadira Gaydaka. So it is a little bit stunning. So Nadira Gaydaka, and I have a Petrel folder and PTD folder for this project, and also now I have a folder which is called nadiragaydaka.sim, which means that it is for simulation. So okay, let's go. The first, we have to define fluid properties. So viscosities, saturations, and other properties of fluid. We have to define all of them. Now, so now I have them. We was preparing them with previous group. Now let me delete it. Yes. So the first thing that I want to do is to prepare fluid properties. Not to do that, I have to go to simulation folder within processes pane. Then I have to go to make fluid model. Okay, make fluid model. So here I can define the name, and I can choose some other project if I want to edit it. Okay, so I can choose edit existing. So now I have only, I haven't any. So now I have to create new. Then here, if you remember, I was talking about different types of simulation. So black oil, compositional, thermal. Do you remember? So the black oil is the simplest one. So let me use this. So also here I can define some properties. For example, which phases I really have in my model. For example, we now can see that I have gas oil contact, oil water contact, which means that above this one I have a gas. So I should define it. I have an oil and I have water. So I have all of them. So, and if I will remove them, those plates will remove as well. So, which means that I have to define the properties for all of them. And if you can see that I have a sign that something is really requires my attention, okay? So, which means that I have to feel something or change something. For example, minimum pressure within the reservoir conditions, maximum pressure, temperature, and reference pressure for this temperature. And other things, I have to define all of them. And if I would be working on a real field, I would have data to fill those places. But now I haven't any data from a field. That is why I can use something for default. Okay. For example, if I have dead oil, I can choose this one, and all those properties would be defined. I can choose light oil, and the properties of gas and oil, water would be changed as well. That's why for now, let me choose light oil plus gas. So all the data is defined here. So actually, for me, it's okay. And for gas, so if I will change the preset, so the name will change as well, and the data will should change also. But now I need to define light oil. Here we have an opportunity to change the density on gravity API or density kilogram by cubic meters, bubble point, pressure, and other things. So I also can change it by myself. That's it. And this is the only part where I should manage manually. So the first thing that I can see that is this pane requires some additional information on contact set. Okay. In order to do that, I can go to models. So and find this contact set and upload it. And the reference datum pressure and all the other thing would be defined by this two contact by these two contacts. So I can click this one, field table from contact, and this part would be filled automatically. So do you remember that we have defined gas oil contact at this depth? Do you remember? So, and the oil water contact was defined as on a depth 2,000 meters. So that's it. And now we are okay with this pane, and I can just click OK. So here you see something appears. So which is called fluid, light oil plus gas. So we have gas formation volume factor, gas viscosity, saturation pressure, oil formation volume factor, oil viscosity, solution gas oil ratio, water contact set. So the pressure on the contacts and other all required informations are available now. Great. So which means that we are okay with this first step. So now we can go to define rock properties. So I have to go to processes pane again, and we can define what is it? We can define make rock physics functions. So here again, I have a lot of different tables to fill, and I can define the parameters which I want to deal with. For example, if I will remove water, something disappears. So, but I have to set prepare settings for all three phases, and I can use preset again. So I can choose sand, I can choose shaly sand, fracture, or something else. And now let me choose a preset for sand. Okay, so what does it mean? It means that now I have a critical gas saturation. So here it is. So this is a oil saturation with respect to the water. So water minimum water saturation and so on. So in order to be able to read this data, we have to be aware of this table, okay? So which is called relative permeability curve. Have you heard about it? Great. So let me tell you just a few words about it. So this is relative permeability curve, and you see that this curve defines relative permeability of water, and this curve defines relative permeability of oil or gas. So not both of them, but one of them. So, okay, with respect to the water saturation. So, as you can see that water saturation increases not from the zero, but from, I don't know, 20% or 15% or something, which means that we have a critical water saturation, irreducible water saturation, and other things. So if you are really interested in studying this curve more, I can give you some. Okay, that it's not a problem for the disk. So так, нет, видишь, там отображается только тот монитор, вот, поэтому только та мышка будет видна. So, да, вот та мышка видна, вот это не видно. So, if you are really interested in studying this plot, so you can ask me and I will give you some additional information. But this would be too long to discuss it within one what is it, exercise. So stop doing that, guys. Okay. So what is really important to understand for this plot is that when the water saturation is really minimum, the mobility of oil is very high. So mobility considers the permeability of oil. So permeability of oil is very high when there are almost no water, but it is very low when there are a lot of water. So I think it's obvious that and vice versa, the relative permeability of water is very low when the saturation of oil is very low. So that's it. And also we can compare it with production time. So if we would be producing a hydrocarbon for a long time, and the saturation of water will increase. So, and that's it. Okay, so all of those data can be found here. And so also we can define capillary pressure. So capillary pressure, yes, so yeah, that's it. We can just use correlation for oil water, and if we would have some additional data, we can change these numbers. But for now, let's leave it like this. So if I will click apply, something will appear here. So which is called rock physics function. And in particularly, it is prepared for sand. So it is oil water relative permeability and so on. And actually, we can open function window, and we can look at this data. So here it is. You can see that the permeability of water starts from 0.2. Okay, not from 0, but it's increasing very slowly. But after, it starts to increase more and more. And also, for example, we can edit those plots here manually. So that's it. And we can study gas oil related permeability. We can study capillary pressure. Here it is. So capillary pressure is really depends on water saturation. Okay, when there are 100% of water, there are absolutely no capillary pressure, because in order to have capillary pressure, we have to have at least 2 phases, and only between 2 phases capillary pressure can appear. So that's it. This is, and also I can edit this plot. Okay, have some questions? No, in this case, let me say that we have prepared relative permeability, and porosity curves, but now we have to prepare compressibility. Okay, in order to do that, I have to go into another pane, which is called compaction. And now I can also use presets. For example, I have different things to choose: consolidated limestone and consolidated sandstone. Let's choose it. And the numbers would be prepared. For example, minimum pressure, maximum pressure, and the amount of so value of compressibility, and the correlation of law is defined here. So that's it. For now, I'm happy with this, and I can just click OK. And now again, something appears. So you see, even if it's one window, I have two different panes, and if I will click apply to each of them, I have different results. So don't forget about it. And now we have completed compressibility. That's it. We have finished second step. And now we can go to development strategy. So what is development strategy? Development strategy is actually strategy of producing hydrocarbon. Okay, so which deals with production rate, bottom hole pressure, tubing head pressure, reservoir pressure. So it deals with a bunch of different properties, which really affects the productivity, the production rate, and all the production processes. So now let's try to prepare something. So in order to do that, I have to go to development strategy. Yes. So here I have a development strategy. And for now, it is development strategy 1 and simulations. The first thing that I have to do is to choose which simulators I'm going to use for this simulation case. Okay, so you remember that we have Eclipse 100, Eclipse 300 or something. We have even Intersect, which is very powerful software. So we can click all of them, but you know that higher the amount of data, higher the simulation time. So that is why I can remove all of them and just leave only one, the simplest one. So, and you see that strategy type. So we have two strategies, as I told you on the lecture. So it is a history and prediction. So you already know that in order to run a history matching, we have to have some history data. But for this project, we don't have any. So what we are able to do is just to make some prediction. So which means that we are going to run the simulation without history matching, which means that we're going to run a simulation without knowing is this model good or bad. Anyway, we have to have some practice, and that's enough for us within this course. Okay, so let's pay attention for the left part of this window. So you can see the, what is it? Date, that's right, and we have another date. So the interval between them is 20 years. So which means that we're going to simulate the field for 20 years. Okay, so we can change it. For example, yes, let's make it for 20 years. That's enough. Okay, because it would be running for half hour. Okay, 3 years is enough. And we can add another things, okay? Which means that if I will put something, for example, here, between this interval, during this 3 year, for example, I can have only 50 wells, and during another couple years, I can have not 50 but 100 wells. Anyway, something will change year by year, which means due to this fact, I can define different time steps. Okay, so different days, dates between which I will have different processes. Okay, so yes, I don't want to go too much with this. So now, between this time interval, between this 3 year, I have to have some wells, but now I don't have any of them. So which means that I can upload some of them. So you have to know that in order to put a well here, we have to put a perforated well, prepared well, okay? And we know that we didn't apply any completion for all of those wells, but now I have this one, which is perforated, so I can upload it now. Okay. Аня, так. So now I have uploaded my simple well between this interval. So, and which can be found within this wells folder. Okay, that's it. And now I have another folder for groups. So automatically I have a group. So Petrel prepared the group. If I will upload all of those wells, I would have one group as well. So let me show you. All of them would be applied to one group. But you see that we have A group, we have B group, we have C group. So, which means that I can split them, for example, like this. Yes, and I can define different strategies for different groups. You see? Yes, but now let's skip it. We don't need to use them because it's useless. Yes, it's useless. So this, for example, why do we do have the wells folder and group folder? Because of the last folder. So here we have rules folder. So in this folder we have comment, okay, which is meaningless, just giving some hint what to do with this folder. So we have to apply some rules, and then we can apply reporting frequency. The reporting frequency is each year. So we have 3 years, which means that we will have only 3 reports. We can change it frequency each year or each day or each hour, each second, okay? So we can change it. And let's say, yes, let's leave it like year. So, but what this is not all about this folder. We have to define some rule here. So open add rules dialog. Okay, here it is. For example, this is a Schlumberger rules folder. So general, devices, groups, wells. Okay, let me start with groups. Oh no, let me start with wells. So let me give you an example. Well, for example, oil injection well, oil injection control. Okay, so I have defined this one, and new rule appears, and which means that I have to define some well, for example, this one here. And now I have to define amount of liquid which would be injected in a reservoir by this well during 3 years. Okay? Okay, give me some feedback. Oh, great. Yes. Now, for example, control mode. It can be group control, it can be surface rate, reservoir rate, bottom hole pressure, tubing head pressure, and group control. So let me discuss it. So let me tell you what it is. So surface rate. So let's assume that we have surface facilities, we have Xmas tree, okay, and we have a well. And here we can calculate how much liquid, for example, water was injected, okay. For example, we have injected 1,000 cubic meters, and it would be true for surface rate, but this volume of liquid would be different in reservoir conditions. It would be more or less. You think so? Well, I think it would be a little bit less because pressure is much more higher than here. So, for example, let's say that it is like this. I don't know, just random number. You see? But also we have another control. For example, when we are dealing with injecting or producing, we have to have with delta P, always. We have delta P between tubing head pressure and bottom hole pressure. We have another delta P between bottom hole pressure and reservoir pressure. Agree? Which is very crucial rather than calculating amount of liquid. Because if we will inject less amount of water than it is required, the depression would be, so delta P would be not so effective, for example. But if we will upload too much, the delta P would be very high, and we will get some fingering very fast. Okay, that's it. So due to this fact, we can define the control for bottom hole pressure or tubing head pressure. And the last one is group control. So what do you think? What it is? Some just ideas. What it is? Tell me something. Yes. Just some crazy ideas what group control is. That's right. Маржан Симба? Ты же знаешь. Так же неинтересно? Just, okay, come up with some crazy idea. Подайте воду. Okay, crazy ideas, come on. Thank you. Break. So let me finish this part at least, okay? Okay, I don't know. I don't want such crazy ideas. They are too much crazy for me. So group control. So all of these things which I told you is just for one well. But now we have to discuss what is group control. For example, if I will have a bunch of wells, and for example, which is called, I don't know in English, объект разработки. Okay. So, and I can define the, for example, here I have, for example, 50 cubic meters per day. Here I have 100 cubic meters per day. Here I have 200. Here I have 60, and so on and so on and so on. But due to, for example, more general reservoir engineering things, for example, let's say that we have to unify somehow the production from this object, which means that for all this object, we will define production, daily production, let's say 1,000 cubic meters. Okay, and in this case, we have different productivity index for all of the wells. We have different productivity index for all wells, which means that, for example, if we will have 10 wells, we cannot apply like 100 for this, 100 for this, and 100 for other. In total, we will have 1,000, but this is not correct because we have different productivity index. And Petrel will manage it by itself. Also, let's say that one day our well dies. Okay, and so which means that we have to make some workover. And now we have not 10 but 9 wells. In this case, group control will manage this as well, and those amount of hydrocarbon which should be produced from this well would be shared for other wells. You see? That's it. But now let me choose bottom hole pressure, and let's no, I don't have so much information, so let's say just surface rate, and I can define that I have to inject not 1,000, let's say 500 cubic meters per day, and should be, for example, this amount of, so this is standard cubic meters, this is reservoir cubic meters per day. And I can define other things and so on. You see? Yes. That's it. So let's validate. So now it's okay. And so let's define like injection. So, okay. And now I have development strategy, which means that now I have all 3 steps ready to go. So now, let me show you the last thing before the break. So, define simulation case. This is the last step. Define simulation case. So I want to create new one, which is called injection lift, let's say. And here again, I can choose the software by which I should simulate. Now, if on this computer, Petrel and Eclipse are joined between each other, and I can use it. So now, the type of a model: single porosity, dual permeability. So okay, I have only single porosity right now. So okay, and here I can choose a model which I'm going to simulate. I have only красавицы. So here, very important, how much cells I do have. I have 10 million cells, which is very high, but you should have amount of cells which is lower than million, okay? So that is why you have to be aware that you don't have so much cells, or you will lose precious time. So now, by default, you would have something like this. But so if for example, if I will open the properties, you see that I have permeability property. If I will prepare petrophysical model for permeability, I would be able to upload it here, but it doesn't make sense because it's just scale-ups. That is why I will define it manually. So this is I, this is J, this is K. So Z, Y, X, Y, and Z. So on X, Y, let's say that anisotropy is very low, but for Z, it should be very lower than this value. Let's say 80, for example. For the porosity, I can upload something. So let's check. So here it is. I can upload it, yes. And also, if you remember, we have a net gross. If we will have a model for net gross, we can upload it here. Otherwise, we can define something by ourselves. Let's say, yes. And next thing is functions. The first is drainage related permeability. Here I can upload this sand. Then black oil fluid model. Black oil fluid model. Here I have to upload this one. No, not this one. I have to define contact sets. So, and for rock compaction, I have to upload this one. That's it. We are good with this pane. Strategies. I have to define some strategies. So let's open it. That's it. Advanced settings. We are not going to change advanced settings. And results. So here we will obtain, so we will define those plots, those graphs, which we want to have. If I will click everything, Petrel will generate all of them, but it would take more time. So here are some of them. Gas oil ratio, gas injection cumulative, okay. So this for group, this is for wells. So let's remove group because we have only one well. So now we're going to define them for only one well. So let's leave it like this. So this is a field. So okay, let's leave it. We have also a lot of other different things to define: diffusivity, so some matrix blocks, ratios, net gross ratio, and really huge amount of different plots to prepare. So let's skip them. This is too much for us for this course. So now I think we are ready with this. And let me show you something. You see that if I open my simulation folder, here I have 4 different folders for simulation. And now, if I will check, so come on. So if I will click check, new folder will appear. Yeah, here it is. Injection folder appears. And now Eclipse is running. Eclipse is running in order to check, do I really have some errors or not? Okay. And it will take not so much time. But if I will click run, it would be running all the model, but it would take more time. But you know, you have to see the difference. When you're clicking check, we are not getting plots. We will just check the model for some errors, for having some errors. But if we will click run, it would be time consuming, but we will have result. we will get some model simulation. But what is nasty, not nasty, but inconvenient with this? For example, it can run for 1 week, or let's say 2 days, and after 40 hours of simulation, if we will have some error, everything would be in vain. That is why first we have to check, after which we have click run. Okay. So now you see that Eclipse is calculating is there some any errors or not. It's checking. And for this time, let me show you what Eclipse model consists of. So huge amount of data. So so if we would be talking about Petrel model, we will have two files, which is called Petrel. So this one, let's say, Yarosol Pet and Yarosol PTD. Okay. In our case, we have data file. Yes, we have data file, this one, which is running Eclipse, and all other data is supplying this data file. So if I will open it, I will have really huge amount of different things. And for example, I have include file. So let me calculate how much include files I do have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 include files. So let me show you one of them. For example, props. So I will open this. I have opened this. You see that here is general information. Here it is note that everything was generated in Petrel. And here we have the information about rock properties, the compressibilities, PVT properties of water, PVT properties of oil, PVT properties of gas, density of oil, density of water, density of gas, and all other properties. And we have 13 different folders like this. Some of them are much more higher, huge, much more bigger than this file. Okay? Some questions? Okay. Now we can see that our checking process have finished. So if I open injection file, so here all those files was created just right now. And now this is my data file, which is the main file, which is running all the process. And what is important for me is to find PRT file. PRT file. And if I will go just to very bottom, I can have the summary, error summary. So I have one comment, I have 3 warnings, 0 problems, and 0 errors. This is the most important part. If I have 0 errors, it means that I can run the simulation. And now I'm running the simulation. And it will take, I don't know, a couple minutes. And now I think that we are good with this lesson. So if you will like this lesson, subscribe, push thumbs up, and share this video. And if you will have some other questions, you can write and I will give you the feedback. So bye-bye.